Have you ever wondered why, on a sunny day, a black t-shirt feels way hotter than a white one? Well, the answer is all about a really cool area of physics called black body radiation. And in this explainer, we're going to break down everything you need to nail this topic in your AQA GCSE Physics exam. So here's the plan. We'll start with a rule that applies to basically everything in the universe. Then we'll introduce the perfect black body. It's a super useful idea physicists came up with. We'll look at how temperature changes the whole game, then we'll get into the really crucial higher tier stuff about thermal balance, and finally, we'll wrap up with a checklist of everything you need to remember. Sound good? Let's get into it.
Okay, first up, let's just go straight for that t-shirt question, because honestly, it gets right to the heart of what this is all about.
The answer comes down to a fundamental rule of physics that you've just got to know. All objects, literally all of them, are constantly giving off and taking in radiation. Yep, that's right. Everything around you, this screen, your desk, even you yourself, is in a constant, invisible dance of energy. You're emitting it and absorbing it right this second. This is a core fact, one of those things you absolutely have to have locked in for your exam. Now, to really understand how all this works, physicists love to use an ideal model. So let's meet the perfect black body. Okay, this definition is pure gold for your exam. You need to know it by heart. A perfect black body is a theoretical object, so it doesn't really exist, but the idea is that it absorbs every single bit of radiation that falls on it, 100%. Nothing is reflected, nothing passes through. It's like the ultimate energy sponge. And here is the absolute key to the whole thing. Anything that's a perfect absorber is also a perfect emitter. The very same quality that makes it amazing at soaking up energy also makes it amazing at sending that energy back out. It's a two-way street. And this brings us right back to our t-shirts. A black t-shirt isn't perfect, but it's a really good absorber of the sun's radiation. A white t-shirt, well, it's the opposite. It reflects most of the radiation, which makes it a poor absorber, and that's why it keeps you cooler. So just remember the rule: good absorbers are good emitters, and poor absorbers are poor emitters. So, what's the engine driving all this radiation? What's the one thing that connects an object to the energy it's giving off? Well, it's all about temperature. Okay, this is another really crucial point. As something gets hotter, it doesn't just radiate more energy every second. The type of radiation it emits actually changes too. Just think about an electric hob. When you first turn it on, it gets hot, but you can't see it glow. Then, as it gets hotter and hotter, it starts to glow red. That's because it's now so hot it's emitting radiation at a shorter wavelength, one that our eyes can actually see. So hotter means more intensity and a different kind of radiation. All right, time for the higher tier content. If you're aiming for the top marks, you really need to get this next bit. It is all about balance. The easiest way to think about this is to picture a bathtub. If water's flowing in from the tap faster than it's going down the drain, the water level rises. Simple, right? That's exactly what happens when an object absorbs more radiation than it emits. Its temperature goes up. But if the water flowing in exactly matches the water flowing out, the level stays constant. That, my friends, is thermal equilibrium. When an object is at a constant temperature, it's because it's emitting energy at the exact same rate it's absorbing it. And this isn't just some small-scale idea. The same principle applies to our entire planet. The Earth is constantly soaking up radiation from the sun, while also beaming its own radiation back out into space. And look, this quote is taken directly from the AQA specification, which is a massive clue that this is a really important concept. So, for that higher tier exam, you have to be able to explain this relationship. The Earth's overall temperature is the result of this delicate balance. If anything tips that balance, say we start absorbing more or emitting less, then the whole planet's temperature has to change until a new balance is found. Whew! Okay, let's bring it all home. Here is a super quick summary of every key point you need to know from this section for your exam. Let's do a quick fire round. 1. All bodies absorb and emit radiation. 2. A perfect black body absorbs everything and is the best possible emitter. 3. The hotter something is, the more radiation it pumps out per second. 4. Not just more, but the type of radiation also changes with temperature. 5. For higher tier, if the temperature is constant, absorption equals emission. And 6. For higher tier, the Earth's temperature is all about this balance. I'd seriously pause here and try to explain each of those points out loud. If you can do that, you're in fantastic shape. And to finish, here's a final thought for you. This whole idea of radiation balance, it isn't just an abstract topic for an exam.
It's the absolute foundation for understanding our planet's climate and the greenhouse effect. The physics you've just been revising is how we begin to tackle some of the biggest scientific questions of our time. Okay, that's it. Good luck with your revision.